Hi, here is a question that came in one of the final exams of a course in probability and random variables. So the question says that you have two jointly Gaussian random variables, x and y, with their mean and variance defined as in the question and a covariance given by -1. Before we start solving the question, we need to just recall some important properties about jointly Gaussian random variables. So if the variable z is a linear combination of two jointly random variables, x and y, where x is a Gaussian random variable with mu x, mean mu x, and sigma x square variance. Y is also a Gaussian random variable with mean mu y and variance sigma y. Then we know that the variance sigma x square is equal to e expectation of x square minus the mean of x square. Sigma y square is given by the expectation of y square minus mu y square, and the covariance of xy is equal to the expectation of xy, which is the correlation of x and y, minus mu x and mu y. Okay, so if you have a linear combination of two jointly Gaussian random variable, then according to the theory of random variables, z is also Gaussian with Gaussian random variable with mu z equal to alpha mu x plus beta mu y, and the variance of z is given by alpha square variance of x plus beta square variance of y plus 2 alpha beta covariance xy. These are very important formula to remember. So in this question, we have that z is equal to x plus y. So we know that alpha is equal to beta, which is equal to 1. So according to this, we can easily first calculate the mu z, which is equal to mu x plus mu y, and mu x, the mean of x is 1, plus the mean of y, which is 2, so the answer is 3. The variance, as you can see, of x and y, they are both equal to 2, so we can calculate sigma z square equal to alpha square, which is 1 square, so sigma x square plus sigma y square, substituting alpha and beta equal to 1, plus 2 times covariance xy. And sigma x to 2 plus 2 times the covariance of x and y is given by -1. So we can see that 2 minus 2 cancels out, and the answer is just equal to 2. So it's clear that z, the random variable, is Gaussian with mean given by 3 and variance 2. So the probability density function, PDF, the probability density function is simply equal to 1 over root 2 pi sigma z square e to the power of z minus mu z squared divided by 2 sigma z squared, and that will be 1 over root 4 pi e to the minus z minus 3 square divided by 4. And then they're asking us to find the probability distribution function, which is the CDF. So the CDF, or the cumulative distribution function. So f capital Z of z, which is defined as the probability that capital Z, the random variable, is less than or equal to little z. So if we check what this represents, but before we do that, let's first do normalization. So in order to express this probability density function, distribution function, in terms of functions that is well known in science and engineering, which is called the Q function, we need first to normalize it. So first we need to normalize the variable z. And how do you normalize it? By subtracting the variable by its mean and divide by the standard deviation. And whatever we do in one side of the inequality, we have to do the same thing on the other side of the inequality. So that will be the case. Now this is clear that one can check that z here, if we call this variable, this is a variable transformation. If we call it x, then x is a Gaussian variable with zero mean and unit variance. So in this case, this can be written as the probability that x capital is less than or equal to z minus 3, the mean, divided by root 2, the standard deviation. So if you look at graphing this, we know that the probability of an event is basically equal to the area under the curve of this interval. X less than equal to z minus 3 divided by root 2. So in this case, if you go and sketch the Gaussian variable PDF, so that's fx of little x, then if we spot z minus 3 over root 2, so let's say that this is the point z minus 3 divided by root 2, and we are concerned about, then this probability represents the area under this curve. All right. Now, this is the case when z minus 3 over root 2 is greater than 0. Okay, and in this case we have that z is greater than 3. So if z is greater than 3, we know that this probability can be expressed as 1, which is the total area. Okay, 1 minus the area of this region in yellow. But the area of this region is given by the Q function. It's a very well-known function that is used in engineering that simplify the expression of the distribution function of a Gaussian random variable. So that will be z minus 3 over root 2. Okay, so the probability, so when z is greater than 3, so now we can say that this probability can be expressed as, so when z, so it's 1 minus q z minus 3 divided by root 2 when z is greater than 3. Now when z is less than 3, okay, so let's see what happens when z is less than 3. So we know that this is going to be a negative value, z minus 3 divided by root 2. So the probability that capital X is less than z minus 3 over root 2 is given by this area. So this is basically the probability that X, so here this is just the probability that X is less than or equal to z minus 3 over root 2. Because of that, notice that if you take the opposite side with the same value, if you take the positive of this, so multiply by negative, this will be 3 minus z divided by root 2. Then one can notice that this area, using the symmetry, okay, this area is given by q of 3 minus z divided by root 2. Of course, in this case, z must be less than 3. Okay, so for z, and when z is less than 3, then the distribution function f is equal to the q of 3 minus z divided by root 2. And that covers all the interval from minus infinity to infinity. And the q function usually is calculated using the q function table, which is given by this, as you can see, the value of x and q of x. So when x is 0, okay, so we are actually in the midpoint, that q of 0 is 0.5 because it's half the area. So if you look here carefully, okay, so q of x is basically calculating this area. If this is x, so this area is given by q of x. So when x is 0, it means that we are covering half of this region. The full region is 1, half of the region is 1/2, and so on. So as x gets larger, you see that the area reduces. All right, now let's move to the second question. Its second question says, calculate the mean of w. What is the variable w? So the variable w is also a linear combination. It's a combination of certain variables, x squared, 2x squared plus 3y plus 4xy, and we are asked to find the mean of w. So if w is equal to 2x squared plus 3y plus 4xy, then taking the expectation operator on both sides, and we know that expectation is a linear operator, so this will be 2 times expectation of x squared plus 3 times expectation of y plus 4 times the expectation of x times y. So remember, so we mentioned before that the expectation of x squared can be calculated easily from the property here. So we know that the expectation of x squared is simply equal to sigma x squared plus mu x squared, and this will be given by sigma x squared is 2, the variance, plus mu x squared, which is 1. So ex squared is equal to 3. All right. EY, the expectation of y is just mu y, which is equal to 2. And the expectation of x times y, which is the correlation, the two variables x and y, is given by, so we can calculate this from here, which is covariance xy plus mu x times mu y. And the covariance is given by -1 from the question. Mu x is given by 2. Mu y is equal to 1. So the answer will be -1 plus 2, which is 1. So now substituting these values here, so we have that ex squared is given by 3, ey is given by 2, and exy, the correlation, is given by 1. So we have 2 times 3, which is 6. So EW is equal to 2 times 3 plus 3 times 2 plus 4 times 1. So that will be 6 plus 6 plus 4, which is equal to 16. The last question is asking us to find the probability that z squared is greater than 4. So how do we calculate that? So look, the probability that z squared is greater than 4, first of all, we need to get rid of the square, so we have to take the square root on both sides. And this can be reduced to the probability of magnitude of z, or absolute value, don't forget the absolute value, greater than 2. Okay, so this is very important. Many students forget to put the absolute value. So remember that the nth root of z to the power of n is equal to magnitude of z if n is even. If it's odd, there is no need to put the magnitude. So now, because we don't have the distribution function of magnitude of z, we need to get rid of the magnitude. So how do we do that? Remember that the magnitude of z greater than 2, this is an inequality. So this event can be written as the union of that z greater than 2 or union z less than -2. So any z in these intervals will satisfy the above inequality. Therefore, the probability that z squared greater than 4 is equal to the probability of z greater than 2 union z less than -2. So this can be simplified by realizing that this is an event A and this is an event B. So we have the probability of A union B. And according to the theorem of the probability of two union events is the probability of A plus the probability of B minus the probability of the intersection A and B. However, it's clear that these two events are disjoint. Okay, so there's no intersection. Because they are disjoint, then probability intersect B is equal to the empty set or the null event. And the probability of null event is equal to 0. So therefore, we can write the probability that z squared greater than 4 as the probability that z is greater than 2 plus the probability that z is less than minus 2. Now remember, in order to solve this probability, we know that the cumulative distribution function f z of z is equal to this. All right. And we know that the probability distribution function is defined as the probability that is capital Z less than or equal to little z. So for the second probability, this is straightforward. Okay, so what is the probability that z is less than minus 2? First of all, minus 2 is less than 3. So minus 2 is less than 3, which means that we're going to use the first Q function. So in this case, this is equal to the Q of minus 2 so just to correct this here, this should be 3 minus z. All right, and z is negative, so we have Q of 3 minus 2 divided by root 2. So the answer is Q of 5 over root 2. The probability that z is greater than 2 is equal to, since 2 is positive, but this is greater than, so we need to switch it to less than, so it's 1 minus the probability of the complement event, which is z minus greater than, less than or equal to 2. And because this is less than 3 as well, so this will be 1 minus Q, 3 minus z divided by root 2. So the answer is 1 minus Q of 1 over root 2. Therefore, the probability of z squared greater than 4 is equal to 1 minus Q, 1 over root 2 plus Q, 5 over root 2. So let's try to calculate Q of 1 over root 2 and Q of 5 over root 2 using the table. So Q of 1 over root 2 is approximately equal to 0.7, and 5 over root 2 is approximately equal to 3.5. So in this case, 0.7 is given by, is here, and this is Q of 0.7. So Q of 0.7 and Q of 3.5. So 3.5, this is Q of 3.5. So in this case, the probability is equal to 1 minus 0.24196 minus 0.0023263, and the answer is given by 0.75781. That's it.